Today I will be doing problem 5.6 number 4. I'm doing part A. I'm not doing part B also because it's just doing the same thing twice. And the problem asks us to use substitution formula to evaluate integrals. And they give us this integral of pi over 6 going to 0. And the equation is 1 plus sine 3t cosine 3t dt. And the first thing we need to do to use a substitution is to transform this integral so that we get g of b to g of a f u du. And so this is how we're going to transform it to this. So step 1 is we need to decide what u is. And we look back at here. When finding for substitution, you want to look at each part. And I broke it up into two different parts, the 1 plus sine 3t and the cosine 3 dt. And usually I pick the one that's not connected to the dt, and I look at it quickly, and in my head I find the derivative of it. And if the derivative is similar to this, then I use this for u. So I'm going to pick 1 plus sine 3t for u. So my u is 1 plus sine 3t. And then our second step is to find du. So the derivative of u with respect to t is, we have the 0 plus, becomes cosine 3t times the derivative of that is 3, which is equal to 3 cosine 3t. Now, since we know that u is 1 plus sine 3t, this part, we want our du to equal what's left. We want our du to look like the cosine 3t dt. And if you look, it's close. Oops, I forgot the dt. It is close, but there's this 3 here. And so what we want to do to transform that is we're going to divide by 3. And since we have du equal to this, we're going to divide the du by 3. And when I rewrite that, I like to write the fraction out in front. So I write 1/3 du equal to cosine 3t dt. And if you look, the cosine 3t dt, cosine 3t dt, and then the u, the 1 plus sine 3t, and the 1 plus sine 3t. And now, knowing this, we can use our substitution, and we have from pi over 6 to 0, we have u, the first part, times 1/3 du. And to make this, because we're evaluating it and it's not indefinite, we're finding an actual solution to this problem. To make this even simpler, we also are going to transform these integral values here of the pi over 6 to the 0, and we're going to transform that using u. So again, u is equal to 1 plus sine 3t, and we're going to use u to change. The original was pi over 6 to 0. We're going to use u to find new values for up here and a new value for down here. And when doing this using u, we're going to say when t is equal to pi over 6, what does u equal? And when t is equal to 0, what does u equal? And all we're doing is taking pi over 6, plugging it in and solving it to get this value, and putting 0 into this, plus the 1 to get our two values. And when we do this, we get 2 and we get 1. So instead of pi over 6, put 2 up there. Instead of the 0 down here, we can put the 1. So to make that look a little clearer, our new thing is 2 to 1. Now, knowing that part here, I'm going to flip to a new page. Our new integral will look like 2 to 1. And then, when looking back at this page, the u 1/3 du. Now our next job is to integrate this section here. So when I like to pull the constant here out in front, so I write 1/3, And then we add a power to the u, so it becomes u squared, since it's an imaginary one up there, all over that power, 2. Which then we write this out, then we get u squared all over 6. Now, when evaluating it, from 2 to 1, we use the fundamental theorem of calculus. We have the f of b minus f of a. And that's going to give us our value. So we plug in this b value, and then we plug in the a value into this equation here to get our final answer. So from u squared over 6, we get 2 squared over 6 minus 1 squared over 6, which when we solve that, we get 1/2. So then our answer for finding by substitution what from pi over 6 to 0, 1 plus sine 3t cosine 3 dt, when we solve that, we get 1/2, and that's how you do problem number 4 from 5.6.